Welcome to the finished product of part 2 of the Atari ST refurbathon. Let's get to it. Since I have 8+1 Atari refurbishments that I need to go through, and I might make a video on all of them, I might not, but the intent is if there's anything different about the refurbishment, I'll try to show those details that are different about this one versus the prior one. Where they're the same, I'll just show you the end result. Since you can always go back to the previous video and see, for example, how did I wire up the PSU that I built, the mean wheel PSU? Or how did I program the Gotek, right? I don't want to keep doing it over and over and over because it's the same thing. It's no fun to see the same thing over and over and over again. But where these things are different, we'll focus on. So for example, this Atari 1040 ST, I did a couple things different. This one has a dual TOS switcher, and so I came up with I think a relatively clever way to use the switch, integrate the switch. I debated whether or not I would remove it, but I kept it in there and I integrated the switch in the case as it is without drilling any holes. Two, something else that I did that for the first time ever, I talked my wife into letting me put the case in the dishwasher. And so this clean case is the result of it going through the dishwasher. All right, there's probably some other things that are a little bit different about this one versus the other, but you'll see that in the content here. Looks good. All right, welcome back. This is Atari ST 2 of 8. I'm working on a bunch of other ones, and there's a lot of other stuff to do here. But this one's a little special. Number one, it has this funky socket for the sound chip, the Yamaha sound chip. Yeah, seems to work. I know this tested working per my notes. It does have something special with it. Over here, we have a ROM switcher. So the ROM chips, the EEPROMs that are on the board here are, rather than 27C256s, they're 27C512s. So they actually contain two different distinct ROM images, TOS 1.0 and TOS 1.4. Honestly, I've seen very, very little reason to ever use TOS 1.0. Maybe there's someone out there that has a use case where that it must be TOS 1.0. I have yet to see or experience anything like that. TOS 1.4 is fine, and I don't like having holes in cases or parts sticking out of cases if I can avoid it. However, this case has a hole, an opening for an RF modulator. I will not put an RF modulator in any Atari STs that I work on, just because. However, because we have this opening, I might just see if I can't leave this in and make a toggle switch in the back without having to modify anything. I hate modding cases. If I can avoid it at all costs, I do. All right, let's get to it. Okay. Before testing any further or working any further, I need to test out this guy, and we'll perform two tests. Obviously, we have the Ultima 4 test, and we have the diagnostic card test. We'll start with the diagnostic card test. That'll also let me know which TOS version I have, which toggle it's on right now. And here we go, power's on. Oh, no, plug's not in. Plug for the monitor is not in, and plug for the PSU, the computer, is not on. All right, now we're back. Power on, lights on. Oh, well, something happened. That is wonky. Let's do a reboot. Interesting. Something's up with the glue. Let's take a look at on the timing. The MMU, fail at cycle 1. Interesting. Let's see if the TOS, switching it to a different toggle, adjusts that at all. It's TOS.1.0. Let's try one more time, see if that's, make certain that that's the case. All right, so there's some issues here. I didn't see these the last time, so there we go. Let me do one more test. We're going to do the Ultima test real quick. Even though it failed at the very beginning, the diagnostic hurt test, which we will pull out. Let's just see if we can get it to boot. Ultima 4. But because of some of the issues I'm seeing with at least the shorter to ground Atari ST, I'm probably gonna have some extra ICs I can work with. So I always have an extra MMU and glue, but we're gonna take a look at the MMU in a second. It sounds like it's booting just fine. I don't know if you see that video sketchiness here. The flickering here on the screen. Something, yeah, there's some issues here. All right, cool. We'll figure this out. So, hey, we have a fun problem to work with. It does boot Ultima 4, but there are video issues, as well as it doesn't pass the timing diagnostic. All right, let's try this. Since the little deoxit on here, we're going to try a 35A again. This guy didn't work last time. Let's see if we get anything better. No. We are not getting anything now. We plug the keyboard back in. We have replaced the glue chip. I'm gonna I actually had an issue here where the diagnostic cartridge seemed to not be being read. Let's take a look. All right, so I'm gonna try the diagnostic cart now again. I have a feeling that the cartridge slot actually might have some issues with it. And we'll work that back and forth. I'm glad I got to pick this one because this is a little more interesting and is not a typical repair, at least for the moment. All right, let's see. Nothing. Interesting. I'm gonna unplug the keyboard. And there's something going on with the keyboard. That is weird. So the keyboard being plugged in is causing an issue. I've never seen that before. Weird. All right. And I'm not sure if it's saying the issue is due to the keyboard not being connected or if it's a timing issue, because you don't see the glitchiness anymore, right? Let's try the older keyboard. That's just to see if this drives any change. Something is up with my keyboard here. Not sure what. That is weird that my test keyboard is causing issues. We're gonna do a couple tests. Let's do RAM test. All right, RAM is good. I'll do timing. Yeah, that's good. OS and ROM. Looking good. Let's, obviously I can't do the audio because I don't have any audio plugged in at the moment, but I'm not worried about that. That rarely causes any issues. Where's keyboard? Keyboard. All right. The only one that seems to have a little bit of an issue is that shift, the left shift key. But other than that, it's looking good. I'll do OS-ROM. Oh, I already did OS-ROM. All right, so it's looking good. So I swapped out the glue chip, added some deoxit. That looks like that was the issue. But let's do the Ultima 4 test, make sure the screen's looking good. I've pulled out the diagnostic cartridge. We're now loading up Ultima 4. And that wasn't an issue before, it was more of just the glitchiness in the video. I'm still not sure about the ROM switcher. And I'm going to try the original glue back in here, glue chip back in it, just because it might just have been a deoxit, a contact issue with just some corrosion on the pins. We'll fiberglass pin the legs, the contacts on the original chip as well. Yeah. No glitchiness whatsoever. All right, be right back. Test out this keyboard again because this is my favorite test keyboard and I don't want to have any issues with it. I'm hoping it was just a deoxit thing. Let's get where'd my diagnostic card go? There we are. Get you back in here. It could have to do with the cartridge port. Let's see. All right, I think it was just the cartridge port issue. And the glue. Probably the glue oxidation. All right, so let's power this guy off. Be good to go. Now the nice thing about this one chip is that I can easily differentiate between what I typically have. Most of the glue chips that I have are the 25915-38A versus the -38. So we are going to get the fiberglass pin on the 38 and clean off the legs. All right. I need my eyes. There they are. I actually really like what Chris Edwards, Mr. Amiga Fixer Guide, calls these things. He calls them his eyes of, or helmet of goober. All right, here we are. These look pretty good. All right, let's get this chip back. All right, pop out the 38A chip. Gently. Gently, gently, gently. Pop back in the original. And I do have the bracketry to put on that socket. I might put, I'll probably end up putting it on. I've got tons of those brackets. All right. Let us test out diagnostic cartridge. Huh. Let's just check the diagnostic cartridge again. Make sure it's in and seated well. Huh, maybe it is the glue chip. This cartridge slot feels really weird. The cartridge port is just feeling a lot weirder than normal. No? Okay. Let's see if we get floppy. Nah, nothing. All right. Maybe it is just the glue. I'll try that again. All right, one sec. Pulled it out. Let's put it back in. Just make sure we're not shorting out on the floppy drive. No, everything looks good with the floppy drive there. Cartridge. Yep, it's the glue chip. That glue chip is not a good one. I think we're good to go now. At least with that part. I do say that that cartridge slot does feel weird compared to, I mean, many Atari STs really never ever use those cartridge ports. So I can see it feeling stiff. It could just be brand new with some oxidation on it, blah, 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 blah. But, all right, I think we have everything that we need in order to progress to the next step. Next step, I do want to, I'm going to try to see if I can't run this switcher through the RF out hole. And if I can do that, I might just leave it in. Otherwise, we're going to remove it, and I'll reprogram the EEPROMs there. All right, here we have this TOS switcher, and looks like we can actually get it out outside through this opening. Like I said earlier, I'm not the biggest fan. Here, let's turn this around so that you can actually see what I'm doing. And we'll just adjust a little bit lower. So as you can see, we have with this lovely little switch here, we've got a washer, and I think this will be big enough to fill this guy up. Is it perfect? No, but it's a better use than having a hole here. And this is the only free case that I have. I would have a hole with any of the other computers. All of the other motherboards that function do not have an RF modulator in them. So, hey, let's take advantage of it. Let's call it a feature. These legs here are set as either high or low, depending upon the switch. And if they're set to one mode, whether it's high or low, let's just say it's high. High, it picks the first bank of that 512 bits within each of the ROM chips, right? Picking ROM TOS version 1.0 or 1.04. And then if you flick it off, it'll take the high to the low, and then on this pin 1, and then select the second bank within that ROM space. So by doing that, you're able to tell the computer which ROM to select from. Nice and simple. Nothing too complex about that. But the cool thing is, this board is now functional. Now, I just did something stupid. Although I can always loosen this up again. This case needs a lot of cleaning. I am currently, as I mentioned, testing out the dishwasher on the dirtiest of the dirty cases that is broken. We'll see how that turns out, and then we'll get to some of the next steps, right? So I don't think I'm going to do a detailed deep dive into each of the other steps that I did in the last video, but we have another Gotek. Well, that's not the Gotek, that is the mount, the 3D printed mount. That's the Gotek. We're gonna have to do the Gotek. As I mentioned earlier, I have a frame. I need to remove this, and this time I will video this. I am not going to desolder these guys. I'm just going to clip them, and just clip these, and this will go relatively quickly. And to those of you who pointed out that I was using, and I'm glad that you did, when I pulled out of that Australian, European, I don't remember what style of kettle connector we were looking at. I pulled the brown, which is typically live in the country where that cord is used, and blue is neutral. I reversed them because I thought, hey, black is closer to blue. Black in the US is live. White is neutral. Hey, there you go. But now I have my own wire, a Zing Wang wire kit. Excuse that probably got really loud. A Zing Wang wire kit with different colors that I can just leverage this and pick different colors, whether they be white or black or yellow or whatever, and we're good to go. All right, let's, next step is to see how the dishwasher works.
Just a quick break. This here is the case. You can see maybe it's still a little wet. I just pulled out of the dishwasher. I will put a side-by-side of what this case looked like before. This thing was caked with nastiness. It had inside the case, or like this whatever spilled soda, nasty stuff that had been in there for years, caked in there, both inside and out. Just an absolute disaster. The dishwasher worked marvelously. This thing looks fantastic, with the exception of the various different broken spots on the case.
After that amazing success with the dishwasher, I got permission to do this on more cases. So as you can see here, some of these cases that we're using here, or the case that we're using in this build, is in here along with another one, so that we can take advantage of the full cycle and actually putting it through the dishwasher. So I'm running it without a dry on mid-level heat, low heat really, 103 degrees Fahrenheit. And it cleaned it out beautifully. A little bit of detergent in there, and so worked wonders. These cases turned out beautifully. Obviously, the lighting's a little bit different, but these cases are immaculate now. It just did a fantastic job cleaning them, and I just have to let them dry and air dry, and they worked just wonderfully. It's a great way to clean these quickly as opposed to what I typically do with a toothbrush. Lots of scrubbing, hand scrubbing, etc. Dishwasher worked great. I'm going to continue to use it. Okay, we have now this non-functional power supply to remove and replace with this wonderful functional power supply. And this time, as opposed to desoldering things, we're just going to snip the wires, snip the neutral, the live, and then each of these guys here. There we are. And this was really a scary one. There is no shield between this and the metal housing, metal frame down below. Okay, so the process isn't going to be any different than what you saw in the last video that I put, last refurbishment video, other than the fact that I now make certain I have the right color-coded wires. I am not using brown for neutral and blue for live. Hopefully that'll be a little nicer that way. And have some consistent wires for these guys as well. I think I always kept the colors the same. So I will snap my fingers and we will end up with this done. And we're back. And it is all set up and looking good. And you can see white, black, green. We have the right colors. All right. We'll do a smoke test of this guy, then attach him to one of the computers, and then we move on to the Gotek. All right, we are hooked up to the monitor. Let's put this lovely little power supply in. Look at that. The cord reaches just fine. Ah, perfect. We have the test in place. Here we are. 3, 2, 1, go. We have lights. We have image. We do not have floppy drive. Let me check a few things. Voltages here. Let's look at the 5-volt line. 5.1, it's a little on the high side. 11.7, okay. We're okay. I mean, for it not being loaded down, I guess it's should be okay. Something's happening. All right, let's figure this out again. So, it wasn't the PSU. Tested out the voltages. Everything's fine there. It was the other socket over here. It just needed a little cleaning. So, we put a little deoxit. I fiberglass penned the contacts on the MMU chip here. We swapped out the glue. We cleaned up the MMU. And let's go with the power. And here we are. We should dump right to the desktop relatively quickly. If it's working. There we go. All right, now for the Ultima 4 test. Man, it's almost like it's hard to do this stuff sometimes, or it doesn't want to work for me. All right, here we go. There we go. Floppy drive hooked up. Ultima 4 in the drive. And it's making a beautiful sound. The disk loading sound of joy. And we are, let's just make sure, golden. Image looks good. No flickery. All right. PSU is good. Okay, so we're heating this up, the glue gun, which is a wonderful thing. We're going to solder in just some headers for these lovely OLEDs. I've got my rotary encoder. This is part of the Gotek, but we're going to do this first and foremost. Get this all done. Simple as that. Quick and easy. Let's zoom in a little closer on this guy. There we go.
right, so what we have here, if you look at it, just need to adjust it slightly. And there we go. Boom. Do the same thing on this second one here. And then we'll solder in the rest of the points on the header. Simple as that. I'm gonna just solder on the rest of the header points here. If I can get it off on the other one, that would be great. There we go. Perfect. This will actually make it so much easier to get this guy in place and get it looking good. All right, I think we got it good. We'll let this guy set while we solder the rest of the parts on the Gotek itself and program it appropriately. All right, there we are, soldered up. We have the programming header, we have the rotary encoder headers, and we're good to go. So next step is to program this guy. I'm not going to show that again. If you want to watch it, take a look at my prior video where I went through this in detail. Awesome.
And
I'll be right back.
We have the final product. Gotek as it is. Now obviously I need to test it, but it's looking good. The one thing I didn't put on here is I'm not a big fan of the piezo speaker, little buzzer, so I left it off. There you go. We'll get the computer assembled again and get this guy put inside.
Right, so we have this nearly assembled, nearly done. Not quite yet, almost. Like I said, I still have to fix the keyboard up, but we can at least get everything else assembled back together. As you can see here, the easiest and actually best way to put this back in the case is to leave the PSU inside like this and build up with the full RF shield. And we have not made it far enough back over here on this side. There we go. Oh, darn it. That's the problem. Problem is, there we go. I needed to get the TOS switch thing in place. And we are good. Hopefully me messing around with this didn't do any damage, but let's get it tightened up and put back where it belongs. All right, I finally, after a lot of messing around, got the hex nut on. So, as I tighten it, it will find its way into the right place. At least that's the way I look at it. So we can tighten. And well, it's looking like it's solidly in place enough. Let's zoom out. Oh, not zoom in, zoom out. Flip this guy around and do yet another test run. And we'll use the lovely dirty keyboard still. That's okay for the time being. Then we can start attaching everything
except for the keyboard. You know what? I'm going to use the long cable keyboard, and the reason is, with the RF shielding on, it is a pain in the butt to use this little stubby cord. There we go. It's so much easier with a longer keyboard. Keyboard cord, excuse me. And I'm banging up, making tons of noise. Sorry about that, guys. Hopefully that doesn't damage your ears too much. I'll try to dampen it out a little bit. All right, let's take a look. We have power. We have the screen. We have Ultima Quest of the Avatar looking like it's loading. And there we go. Bada bing, bada bang. All right, very pretty. We are looking good here, and rock solid. We'll need to attach the case to the motherboard here. We will use the official dirty keyboard, at least for the moment. And you'll see I will have a hard time getting it in. There we go. Everything is in place. Test fit, final test fit here with the actual case cover, top case. Just make sure we're getting everything in. Oops, excuse me. Okay, we are in place. It is in place. Everything is in place. I do need to tighten a few things down a little bit more. Need to clean the keyboard, but let's do the smoke test. And we're going to do the smoke test now, not with Ultima 4, but we're going to do the diagnostic cart smoke test. Power on. And we are golden. Golden, golden, golden. This guy's looking gorgeous. All right, we'll just clean the keyboard and we're done. We're just going to touch up the joystick and mouse ports. Make sure we don't have any dry solder joints here. These actually look really good. I'll just reflow them though, nonetheless. This can be a failure point for the Atari STs, specifically on the 1040s, or the STFs rather, because of the location of the joystick and mouse ports underneath the keyboard. They're subjected to a bit more force than what you would see in a normal port. All looks good. Good to go. Okay. As you can see here, we have some nastiness on some of these feet. I'm going to replace them with new. So what we're going to do is we're just going to scrape them off very carefully, clean these out with some isopropyl alcohol, and then sticker some new on. So I'll be back when it's done.
All right, just a few beauty shots of the after of this computer. It's looking pretty good. Obviously, it could use a retro bright if the final owner decides that they want to do retro bright, especially with the keyboard keys. The main case is looking pretty good otherwise, though. It turned out really good. Was able to keep even the TOS switcher in there and have it as a feature specifically. The computer is working well, testing flawlessly. All right, I hope you enjoyed this time, and number 2, Atari ST number 2 out of the 8 plus 1. Stay tuned for more.